Ever wondered what makes up everything around you, even you yourself? Let's plunge into a world that's all around us, yet often overlooked, the intriguing world of matter. Matter, in the simplest terms, is anything that possesses mass and occupies space. It's the physical substance of the universe, the raw material of all things. Whether it's the air we breathe, the food we eat, the water we drink, or the chair you're sitting on right now, it's all matter. Even we, ourselves, are made up of matter. Yes, your body, my body, and the bodies of every living being are composed of matter. Now, this might seem obvious, but think about it. Everything you've ever touched, seen, tasted, or smelled, that's all matter. It's a fascinating concept, isn't it? So now that we know what matter is, let's dive into the different types of matter that exist. Imagine a rock. Hard, isn't it? That's a solid for you. Now let's delve into the fascinating world of solid matter. Solids are one of the three fundamental states of matter, and they come with some unique characteristics. The most defining features? They have a definite shape and volume. Picture that rock again. It's not going to suddenly change shape or take up more or less space, is it? This is due to the way the particles in a solid are arranged. Picture a crowd at a concert. Everyone's packed in tight, barely able to move, right? That's what it's like for the particles in a solid. They're packed closely together in a fixed, organized pattern. But don't think these particles are just standing still. Oh no, they're like people in the concert crowd, swaying to the music. In a solid, the particles vibrate, but they do so in fixed positions. They can't move around freely. This is what gives a solid its rigid shape and volume. Think about the different types of solids you encounter every day. The chair you're sitting on, the device you're using to watch this video, the food you ate for breakfast. They're all solids. And they all have a definite shape and volume thanks to the closely packed vibrating particles they're composed of. And what's more, the tight packing of particles in a solid also results in them having high densities and being incompressible. That's why you can't squeeze a rock into a smaller size or make a metal bar expand by pulling it. But remember, not all solids are created equal. Some are crystalline, like salt or diamond, with their particles arranged in a repeating pattern. Others are amorphous, like glass or plastic, with their particles not arranged in any specific pattern. So that's solid matter for you, possessing a definite shape and volume. From the chair you're sitting on to the diamond in a ring, the world of solids is as diverse as it is fascinating. Now picture a river flowing freely. That's a liquid. You see, the world of liquids is quite fascinating. Unlike solids, which have a definite shape, liquids are shapeshifters. They take the form of their container, yet they maintain a definite volume, meaning no matter what shape they take, the amount of liquid remains constant. Imagine pouring water from a tall, slender glass into a wide, shallow bowl. The water's shape changes, but the volume, the actual amount of water, stays the same. Now let's dive deeper into the microscopic world of liquids. What makes them so unique? The key lies in the arrangement and movement of their particles. The particles in a liquid are close together, much like they are in a solid. However, they are not packed as tightly. This gives the liquid its ability to flow and take different shapes. But don't mistake this for chaos. It's not a free-for-all. The particles in a liquid are still attracted to each other, but not as strongly as in a solid. This weaker attraction allows the particles to slide past each other freely, giving liquid its flowing characteristic. Think of it as a dance, where each particle moves fluidly around its partners, never straying too far, but not staying rigidly in place either. It's also worth noting that because of these loosely arranged particles, liquids are less dense than solids. But they are denser than gases, which have their particles spread out even further. Liquids therefore serve as the middle ground in the world of matter, balancing between the rigidity of solids and the freedom of gases. And that's the beauty of liquids. They are adaptable, flexible, and ever-changing. They flow, they conform, yet they retain their own identity, their own volume. They are a testament to the dynamic nature of matter, a proof that even in the microscopic world there is a flow, a rhythm, a dance. That's liquid matter flowing and taking the shape of its container. Ever tried to catch the wind in your hand? That's a gas. A gas is a type of matter that is as elusive as it is common. Now you might be thinking, really? Wind is a gas? And the answer is yes. The air we breathe, the wind we feel, they're all composed of gases. Gas is unique among the states of matter. Unlike solids, liquids, and even plasma, gases have no definite shape or volume. Gases are like the free spirits of the matter world. They don't like to be confined. They take the shape and volume of whatever container they're in. If you've ever blown up a balloon, you've seen this in action. The gas inside expands to fill the balloon, taking on its shape and volume. The particles in a gas are far apart and move freely. They're not bound by the same forces that hold together solids and liquids. In fact, gas particles are so far apart that most of a gas is actually empty space. Imagine that. A mostly empty space that still has the power to move leaves on trees, fly kites in the sky, and even power engines. The free movement of gas particles also means they collide with each other and with the walls of their container. These collisions cause pressure. So when you feel the wind pushing against you, what you're really feeling is the pressure of countless gas particles colliding with you. To sum it up, gases are the free ones in the world of matter. They have no definite shape or volume. They take the shape and volume of their container and their particles move freely and far apart. These properties make gases an essential part of our lives, even if we can't see them. After all, we couldn't breathe, fly balloons, or even have weather without them. That's gas matter for you, free and taking the shape and volume of its container. Scene script. Have you ever seen a neon sign glowing at night? That's plasma. Now let's dive into the charged world of plasma, the fourth state of matter. Unlike the other three states, plasma is not commonly found on Earth. But that doesn't make it any less fascinating. Imagine a gas that's so heated and energized some of its particles actually lose their electrons. Sounds like the stuff of science fiction, doesn't it? Well, meet plasma. When a gas is heated to extreme temperatures or when it's exposed to a strong electromagnetic field, its atoms gain such a tremendous amount of energy that they start to ionize. This means they lose their electrons and become positively charged ions, while the free electrons zoom around creating a sea of charged particles. This supercharged state, where the gas essentially transforms into a mixture of ions and electrons, is what we call plasma. Plasma behaves in a unique way due to its charged nature. It's highly responsive to electric and magnetic fields, which allows it to form structures like filaments, beams, and double layers. It also has the ability to generate and carry waves and electric currents. And here's the cool part, because of these properties, plasma emits light, which is why we can see neon signs glow. So, where can we find plasma? Well, if you're thinking neon signs and fluorescent light bulbs, you're correct, but plasma also exists in places far beyond the reach of our everyday life. The stars, including our sun, are made up of plasma. Lightning strikes are another example of natural plasma. Even the space between stars, known as the interstellar medium, is filled with this supercharged matter. As for its uses, plasma technology has a wide range of applications, from neon signs, plasma TVs and fluorescent lights to plasma torches used in waste disposal and the creation of semiconductor circuits. Plasma has indeed made its mark on technology. So the next time you gaze at a neon sign or marvel at a lightning storm, remember you're witnessing the power of plasma in action. That's plasma, the supercharged state of matter. So we've traveled through the states of matter. What have we learned? We've discovered the definite one, solids whose particles are tightly packed, giving them a firm structure. Then we explored the flowing one, liquids, where particles have more freedom to move, resulting in a fluid state. We soared with the free one, gases, whose particles are so spread out they completely fill their container. And finally, we electrified ourselves with the charged one, plasmas, where the particles are so energized they become ionized, creating a state that's not quite gas, not quite solid or liquid. In each state of matter, it's the behavior of these tiny particles that determines whether something is solid, liquid, gas, or plasma. Whether we're looking at a diamond, a droplet of water, the air we breathe, or the northern lights, we're observing particles in action. Remember, everything around us, even us, is made up of matter in one of these states. Isn't that fascinating?